Okay, so now we're going to move on to another set of, oh, keep going here. Oh, that was all the classwork we did, FYI. Okay, so now we're going to talk about fractional exponents. Okay, so what I want you to look at here is this, for example, is saying, whoops, let's grab a pen. This is saying the square root of x squared. That means the square root of x times the square root of x, correct? Well, that would be the square root of x times x. And since I got a set of buddies, that means x comes out. So what they're asking is, well, what does b equal? Well, you'll notice b equals 1. Okay? So now they're taking it to the next level because they're trying to help you figure out, well, what does this n equal then? In other words, how do I make this radical go away? So here we've got our x to the 1. Since it's a power to a power, that's where this 2 comes from, right? This 2 is right here, and the 2 is multiplying the n. In other words, what do they raise this x to right here to make that radical go away? So let's see, I've got x to the 2n, and then here we've got x to the 2n to 1. Well, the 2n has got to equal 1. So then in other words, I can divide by 2, and I'll end up with n equals 1/2. Well, if n equals 1/2, then that means this right here is the same thing as x to the 1/2. In other words, anytime you have something being square rooted, it would be the exact same thing as if you raised it to the 1/2 power. Okay, so all radicals can be replaced by a fractional exponent. What I want you to look for is, here's the exponent. X to the first power is what's inside. And anytime you have a radical and it doesn't have a number, well, there's actually a 2 automatically here. So you'll notice if you take the 1 and put it over the 2, you will get your exponent. So let's try another idea. We've got the cube root of x being cubed. So that would be the cube root of x times the cube root of x times the cube root of x. Well, that could be written as the cube root of x times x times x. You'll notice we have a set of triplets, which means they can come out as x, okay? In other words, once again, we have this b scenario where b equals 1, because if x is out like that, it's x to the first power, okay? Going through that same idea, here they're trying to help you determine what is that n value. So we have 3n equals 1, I divide by 3, and I get n equals 1/3. So let's think about what we have here. The cube root of x, keeping in mind this is to the first power. I can take this and put it over that, equals x to the 1/3, okay? So whatever that number is on the outside of the radical goes in the denominator. Whatever is on the inside, whatever power it is raised to, would go in the numerator. So let's go in the other direction. A to the 1/2 is the exact same thing as the square root of a, right? Keeping in mind there's a 1 here and a 2 here, but I don't have to write either one of those. 36 to the 1/2 is the exact same thing as the square root of 36, which equals 6. But I'd like to, not 3. Sorry. Not 3. 6. I thought it said it, didn't write it right. Okay, there's another way I'd like for you to look at this. 36 is 6 squared, and it's being raised to the 1/2. A power to a power, you multiply them. 2 times 1/2 is 6 to the 1. So that's another way that you can make these fractional exponents go away. And that's the great thing about fractional exponents and getting rid of the radical. A to the 1/3 is the exact same thing as a to the first power with a cube root. Remember, the denominator goes on the outside. It is the root, okay? Oh, I skipped this one. Let's see, this would be m to the 3/2 if I did the power to a power, right? So let's see, if we were to simplify this, let's go back to the last unit we did. 3 divided by 2 is 1. That means we've got m to the first power on the outside with 1 remaining, which means we've got an m remaining on the inside, okay? And this would be the simplified version of m to the 3/2. Because keeping in mind, if I did it the other way, it would be m cubed. There's a set, that's what got to come out. and then this stayed inside. Once again, your denominator is your root, and since this is square root, I actually don't have to put the 2. It's just all of the other numbers. So now 27 to the 1/3. Well, 27 is the same thing as 3 cubed. So a power to a power, if I multiply these, I get 1, which means my answer is 3. The next one, once again, power to a power, 10 times 1/3, that would be x to the 10/3 and y to the 5/3. So now to simplify this, I'm going to have a cube root. 3 goes into 10 3 times, so I got x cubed on the outside with a remainder of 1, so 1 will stay on the inside. And then 3 goes into 5 1 time, so I have 1y on the outside with a remainder of 2, so the remainder will stay on the inside. So our rule goes, a to the numerator goes inside, while the denominator is going to be the root, okay? And here are those. The numerator is going to be the exponent and will go with your base. So now let's try a couple more of these. 32 is 2 to the 5th power, and it's being raised to the 3/5. Well, if I multiply 5 times 3/5, my 5's cancel and become 1, and I end up with 2 cubed, which is 8. And you'll see how much easier that is than if you tried to put that inside of a radical and write it all out. The next one would be 8 divided by 5 will go in at once with a remainder of 3. Keeping in mind, this is your root. Okay. So you have some practice to do here. Just keeping in mind, for example, like this first one, 3 goes on the inside. The 1 would go with it. I don't have to write it. The 6 goes on the outside. So those are things just to keep in mind as you work through these. This right here, it's the same thing. You want to get down to that base because then it'll work out. So in each one of these cases, when you have to evaluate in 9 through 16, make sure you get your numbers down to their smallest base. Up in 1 through 8, all you're doing is rewriting those. You're not simplifying or anything like that. It's just, if it's written as a fractional exponent, turn it into a radical. In this case, it's written as a radical, so turn it into a fractional exponent. Okay? And then the bottom is that same type of thing. You're just going to be simplifying and using your exponent skills.